So you need to download a piece of software. You go to their website, check out their download page, and you see a list of binaries. You know your OS, so you're pretty sure whether you're in macOS or in Windows, but the part that comes after it, so you have ARM64, x64, you're not so sure about. So what is it exactly? Let's take a step back. When you download a piece of software or you write some code and you want to run it, what you're actually trying to accomplish is to have it be executed by your CPU, your central processing unit, which any computer has. A CPU has its machine code, and each CPU has its own instruction set. And so the code you're downloading is basically instructions, machine code that needs to be executed by your CPU. And that's adding registers, comparing, calling functions, interacting with the hardware. There are two big families of CPU architectures. So we have the ARM, and that's the RISC architecture, and we have the x86, and that's Intel and AMD. It's actually more common today is x86-64 for the 64-bit version. So these are the two big families of CPUs. And so if I go to my Mac and I check out and I run the command uname, I can see that my Mac is running and has a CPU whose architecture is ARM64. Macs, since Apple started the M series, so M1, M2, and so on, run an ARM architecture. Before that, they used to have Intel CPUs, so you'd see x86-64. So if we go back to our download page, since we know our OS and we know which CPU architecture we have, we can just download this one. Each OS, so whether it is Linux, macOS, or Windows, has its own executable format. So even if they run on the same CPUs, on the same machines, which ultimately runs the exact same machine code, they have different standards and different executable file formats. So for Linux, the executables follow the ELF format, extendable and linkable format. For macOS, it's the Mach-O format, and for Windows, it's PE, portable executable, and these include the .exe files and the DLL. So the way to think about it is you have the CPU, it has its machine code. We have the two big families, we have ARM and we have Intel and AMD, x86-64. And so each has their own instruction set. And then you have the OS, and each OS has a format for the executable file. So within that executable file, you have the actual machine code that's CPU dependent, that's instruction set dependent, but you also have the format that's OS dependent. That's why when we download the binary, we need to pick both the OS and the machine code and the CPU architecture, because it has within it machine code that's suitable for that CPU architecture. So for this example, we are looking at SQLite. The source code, the C code, is the same for all OSs, and not exactly the same, but almost the same for all OSs and all CPU architectures. But once you compile it, you run it through the compiler. If you're in Linux, you need to format it in an ELF format with some machine code that's specific to your target. So if you want to run it on Mac and ARM64, you need to compile it for that. If you want to run it on an Intel CPU, you need to do it for that. So within Linux, you'd have ELF files different for both Mac and for both ARM and x86. If you want to run it in Windows, you need to have it in a PE format, in a .exe. And depending on the architecture, you have different format. So the file format depends on the OS, and the machine code within it is very dependent on the instruction set that comes from the CPU. Let's take a look at an example. So here I have a Go program that simply prints HiSaf, and if I compile it, I get this executable. If I run it, it does what it's supposed to do. So if we check the type of that executable using the file command, we'll see that it is indeed a Mach-O 64-bit executable, and it's built for the ARM64 architecture, which is the one my Mac has. The Golang build command supports cross-compilation, so we can specify the OS, the target OS and the target architecture, and we can get a binary for it. So if I use this command, I specify the variable GoOS, I set it to Linux, and I set the Go architecture to ARM64, and I build it. Well, if we check the type of that file, we see that it is an ELF executable for the ARM architecture. And if I try to run it, well, it won't work, because although it has machine code within it that's destined for ARM64, the file format is not recognized by my Darwin or macOS operating system. So we can do the same thing, and instead of ARM64, we can set AMD 64. So AMD 64 is basically the x86 64 architecture, and if we build it, not IRD but AMD, and if we build it and check its type, it's indeed an ELF executable built for the x86 64 architecture, which is pretty cool. We can also try building it for Windows. So if we specify the OS as Windows, and Windows expect a .exe extension, so we should see an executable file of type PE, portable executable. And this is exactly a portable executable built for x86 64. If we take Python as another example, Python is not a compiled language, but rather an interpreted one, meaning that when we write a Python program, it's not compiled into an executable file, but rather it's passed to an interpreter that runs the Python commands one by one. So the way it goes, the Python code is compiled into an intermediary format, a bytecode, that's run by the interpreter. So if we use the this module, which is the disassembler, and we provide a function that takes in a and returns a plus 2, we can see the actual bytecode, the actual operations that would be run by the interpreter when it executes this function, which is basically loading a variable into the stack. Python is stack-based, meaning we push values to the stack, run operations, then pop them, and keep going. So we load a variable to the stack, we load a constant, which is 2, we run a binary operation, which is an add, and then we return the value. So these bytecode operations are executed by the Python interpreter, which itself is an executable. So if we inspect the type of our Python interpreter, it should be a Mach-O file because we are running on Mac. And there you have it. So if you were running a Python interpreter on Linux, it would be ELF, and if you were running a Python interpreter on Windows, it would be PE. The Python code itself would be compiled, translated into Python bytecode that would be run by these different interpreters, which are executables in their respective operating systems. Anyway, I hope this has been informative. Thank you for watching. Bye-bye.